Thank you. And if you'll go ahead and put up our title slide for the AWP side. We want to welcome those of you who stayed here to cover the AWP Essentials. We have 3 great speakers, and you've heard briefly from 2 of them already. We're joined by Dr. Bill O'Brien from the University of Texas as our academic participating in the program. And with that, I'll turn it over. Bill?
Great, thanks, Bob. Can you all hear me?
Yes, we can.
Great. All right. That's the common intro these days. Can you all hear me? Well, we're real pleasure to talk to you all today about AWP Essentials, and we're really thrilled to share advanced work packaging beyond the industrial community. So we think we have some good things to share and some good practices, and we're very excited to do that in combination with the lean community because there's some good sharing back and forth, and I think broad alignment amongst the goals. So we wanted to have, we've got a 2.5-hour session here. We'll have about a half-hour break right in the middle. Bob was going to keep us on track there. We wanted to get a little more on your audience background and interests, just to make sure we know who we're chatting with. We'll go through a quick introduction to AWP at a high-level overview from Jamie, John, and myself around, okay, what is it at a high level and what does it mean to me or my organization, and have some Q&A, and then come back for a little bit of a deeper dive into AWP. So what's the evidence, how it works, talk about workplace planning, give some observations, implementation, come back for a final Q&A, and then give some closing thoughts. So with that, we were going to collect some work on audience interests, and I think Stephen, if you're back on, you were going to help us gather a little bit about the audience. Is that right?
Hey, yes, I'm here. So yeah, let me go ahead and share your poll. Just one moment, please.
Okay. Should I turn off sharing here?
All right. So yes, apologies. I was just helping the Lean Essentials team get going as well. So let me move over to the Slido here. Okay.
Wanted to get a little bit more about who was joining the session so we can better customize to you our remarks.
Okay. So as you can see, there's the access information. Now you'll this time be able to select the room that you want to join. In this case, it will be AWP Essentials. And now, are you looking for what is your primary proficiency or what is your primary role right now?
Oh, let's do the proficiency, I guess.
Sure.
Try to get both if we can. Thought we'd have more lean folks here. Stephen, about how many do we have in this room? I'm not sure I'm reading it correctly.
Oh, sure. We have 75 attendees currently.
In this room.
That's correct.
Okay. So folks, if you do please give us some more background here. We have one more about the type of role that you play. We appreciate you filling this out. Just help us help you.
And now you should be able to view the attendee list, Bill and
Okay,
everyone.
great, thank you. I see. All right, looks like this is kind of stopped. Let's go to the next question there, Stephen.
Okay. One moment here.
So this is a little bit of a repeat of what you did in the general session, but we wanted to know for this audience in particular where you were. All right, give it a few more seconds here. We're not quite to the response we were before. All right, glad to see a bunch of engineers and designers in the room. Okay, in the interest of time, I think that's good. Thank you all very much. Tells us who we've got in the room with us, and we appreciate that. And so that'll help as we make our comments. All right, let's go back to our slides here. Okay, so to get started, wanted to talk a little bit about what advanced work packaging is. If you've been around the AWP community for a while, you've seen this slide, and if you're new to AWP, this will be a very familiar slide to you in short order. We affectionately call this our surfboard slide. It's meant to be a high-level overview of what advanced work packaging is all about. And you can see on the bottom, we go through project setup and front-end planning through detailed engineering that covers the blue disc, and then into construction, commissioning, and startup. And a lot of the emphasis on advanced work packaging, which really encompasses that whole project delivery life cycle from initial authorization all the way through turning over to the owner, is very focused on getting the right things done up front. And for those who are coming from the lean community, they'll probably be familiar with that. We have in advanced work packaging, and one thing you'll notice in a lot of the discussion and the way the industrial community thinks and talks about itself, it tends to be very work process focused. We go through in AWP a path of interactive planning through a very structured process that this slide only hints at, where we set up a project. We really want to focus on what we call the path of construction, or POC, and that really is the sequence of how we're going to build the project. And in that, also with that, how are we going to design and procure the project as well? And so coming out of interactive planning sessions and a lot of work with all the stakeholders included, including owner representatives for commissioning and startup, making sure we have the right people in the room from procurement, making sure we have the right people in the room from construction, as well as the design team, everybody there to come up with a realistic way to get a project done in a fast track manner. We suffer because we go very fast in the world and we have fast track projects. And so we need a disciplined structure to make sure the sequence is correct and achievable, and we're not basically shooting ourselves in the foot by being too aggressive up front. At the same time, we want to have the controls in place to make things work well. And so one of the key innovations in advanced work packaging is the designation of a variety of work packages. And there you'll see CWPs and EWPs on the blue discs, construction work packages and engineering work packages. That's all about splitting the project up by discipline or perhaps by trade, depending on how you want to think about it, and to large chunks of work that follow the path of construction for how you're going to execute, and then having engineering work packages, which are not how the engineer or designer manages her work, but rather are deliverables to the project team that is the complete set of work. And these CWPs are area-based and EWPs are area-based as well. If we can deliver the complete engineering on time, and think about that as drawings that holds on them, everything is done, then we can make sure procurement is aligned, and that helps us set up the project for success in the field. When we get to the field, we do what we call work phase planning, where we break CWPs up into installation work packages, which are bite-sized chunks of work for a crew to achieve to actually build the bulk part of the project. And then, fairly new to official AWP nomenclature, we've recently added system work packages, which speak to transferring from location-based construction to system-based execution, startup, and commissioning and turnover activities. And so we have, as a currency of trade in AWP, a very work process-driven system to allow us to repeat on every project, every time, a reliable system of delivery. We use work packages, CWPs, EWPs, IWPs, SWPs as the currency for doing that. Now, across all of this, we focus on having good information management so that information is shared across all the players. And we have good constraint management to make sure that we're resolving constraints before they become a problem and impede progress in the field. So if you're coming from lean and you're familiar with the last planner concept or constraint management, that is fully embraced in the AWP principles, although we don't always use the same words to describe it as lean does. So with that, that's a very high level overview of what AWP is about. It's not about reinventing how we do projects per se, but it is about putting in place a structure to cement good practices with innovations around work packages as the primary deliverables, which is an innovation in how the normal project accomplishes work. So with that, let me turn that over to my colleagues and have them talk about what AWP means to them. So Jamie Gerbrecht.
Bill, let's go back to the previous page just for a minute, just to that introductory, one more just to that introductory page.
Sure.
So, for me, as Dr. O'Brien has shared in the past, to have AWP is to have a wellness program for projects. I can recall about 6 years ago when I first visited a particular project site where the work phase planning portion of AWP was being well applied. And what was so impressive was not just how well things were going in terms of safety, productivity, cost, schedule, predictability, and quality, but also how positive and energetic the site atmosphere was for this team. And to me, this was demonstrating an organizational culture improvement that AWP can bring, along with better positioning the project to meet or beat its objectives. And I've seen this in subsequent projects then that have been applying the AWP fundamentals. So putting this together, several of us that are working with the AWP plus Lean Joint Working Group in CII, we started thinking about these thoughts around the culture of AWP. And we just put together some draft points to consider as we look to further this description of the AWP organizational culture. And I just want to share those draft points with you at this time. and just look through them quickly. So we would say that AWP organizational culture values achievement of the project objectives, of course, by embracing effective planning, efficient execution, and appropriate information transparency. You know, Bill just mentioned information management as one of the key components of what it takes to successfully apply AWP throughout a project lifecycle. And that appropriate information management from start to finish, open sharing of the right information is very important. The second one, the AWP culture, we would say, embodies beneficial team behaviors around caring, constraint management, collaboration, commitment, and confidence. The third item here on care, you know, AWP to me demonstrates care for the field workforce because of the timely interactive planning that takes place early enough in the project to make a difference. Establishing that optimal path of construction, managing those currencies of trade, the work packages, CWPs, EWPs, ultimately issuing constraint-free IWPs that support the safe, productive, and rewarding work-based execution. The fourth point, AWP bringing that collaborative alignment among stakeholders with purposeful planning through the systematic execution using manageable work packages. And that term manageable shows up several times because it's so important. Often on projects, you know, we have the large complex scope and really being able to break that into manageable portions where you can have good ownership of those by individuals on a team or groups of people on the team is very challenging. But this manageable structure of work packaging helps. Number 5, AWP culture inspires a mindset of commitment and confidence for accomplishing the objectives. And what I saw in that team 6 years ago were individuals with smiles on their faces as they talked about the fact that they were going to meet or beat the objectives. They had no doubt. Things were positioned for them to be successful, first and foremost in safety, but across the other performance dimensions as well. Number 6, the AWP cultural aspects promote effective communication and visibility that comes when you have structured planning and you track and report real progress using that common language and the data of work packaging. Number 7, providing work package scopes for team members who can actually own and visualize through their personal roles and responsibilities portions of work, maybe areas, whatever, but they're defined and they're structured well. Number 8, the AWP organizational culture welcoming opportunities for the synergies in AWP training and coordination across the project owner groups, the contractors, subcontractors, supplier organizations, so that all parties can be a part of a well-run AWP program and benefit from that application. And then the last point here is that I see that culture of AWP from an organization standpoint motivating team members to behave as a collective team. And that can increase their desire to really support their fellow team members in creating win-win solutions. This is the kind of atmosphere that I've experienced and I've seen developing. You know, this is only at a time when many organizations would consider their maturity in implementing AWP to be at less than a mid-level of maturity. So, you know, for me overall, it's not only about meeting objectives, but it's about individuals on the project team having a more enjoyable and more rewarding experience. That's a lot of what AWP means to me and to the organizations that I've experienced and working with through my role with CII. Thank you.
Thanks, Jamie. I think, John, you were going to.
Okay, Bill, do I have control? Well, I do. Okay, control over the slides. I live in the a revamp world, and our marketplace is, you know, 80%, probably 90% of our projects are revamp and renovation in the chemical and refining sector. So for us, it's a little different market than one of these big greenfield jobs that are $1 billion or something like that. But we have many small projects that we have to deal with. And Bill mentioned the word fast track. Well, the majority of our contracts are design, bid, build. And it would be really cool if they would let us design the project and then they would go bid it and then they would construct it. But that's not reality. In today's world, our customers want to get from project to making product, as fast as possible. And that means that they're going to start construction before we're finished in design. And that causes a lot of issues. Traditionally design build, you're going to optimize engineering. That's just what you want to do. But if you look at AWP, you've really got to bear in mind the person who has to build this thing. So the big five here is bring construction up front early. As Bill said, the A in advanced work packaging means A, advanced planning. Bring the guy who's going to build it in and help you figure out how to best construct this thing. Then you've got a problem because it's not going to be the best way to engineer it in many cases. So now you've got to get engineering and procurement together and figure out, well, what can we do? What are the issues? What are the risks? And what can we do to build this thing in the most efficient manner that'll meet the owner business requirements? Once you establish that, and by the way, I am the AWP champion for Ford, Bacon, and Davis, so we had to develop a structured process to ensure that we have consistent execution among all of our projects, and we learn from each project and we get a little better each time. Another big principle here is when you're out in the field side is dedicated planners. And what you want to do, you want to have really good craft planners who can build these installation work packages so that we can keep the foreman working with the crew. Now, you may have a general foreman or a superintendent doing a lot of the planning to find out when these IWPs will be installed, but you don't want that foreman running around looking for information, trying to find parts, when it's going to be a constraint-free, and that's point number 5, that field planner is going to prepare a constraint-free installation work package for that craft. They've got everything they need to be productive. I'll tell you a little story. I was at a hotel and went to a conference, and I left my wife in the hotel room, and I went back up to see her to lunch, and she says, I just noticed something. I said, what's that? And they were building another hotel right next. She says, I looked down there at the ground and said there were 12 people sitting on the benches out there eating sandwiches, smoking, talking, and everything for about 2 hours. And I said, well, what happened after 2 hours? She said, well, their trailer came in and brought in a bunch of materials and they went to work. Well, that's not a constraint-free work package, and that's what happens to a lot of projects. So we want the foreman working with the crew, and we want constraint-free work packages to the craft. So let's look at the next slide here. Why construction? And whoops, can I go back, Bill? Not sure how to, there you go. Why construction? Because they've got to build this thing. And especially if you're in the modular world, the sequence of when those modules come in and how they're placed is extremely important. So we got to make sure that construction has the optimum path. That's where you're going to make or break the project. Why align? If you come up with a construction plan that can't be supported by engineering and procurement, you haven't done yourself any good. So you got to get the stakeholders. Is this realistic? Can we really support this path of construction? And all of this needs to be done prior to you doing that TIC estimate at the end of FEL3. So your execution plan has to be in place so that you can estimate this project and design this project so that it will meet that path of construction that Bill described. So that's our 5 big whys for Ford, Bacon, and Davis. Turn it back over to you, Bill.
Great. Thanks. And I think we had an opportunity for some Q&A at this point, or a break for that. I think, Bob, we were monitoring the chat and see if anybody had some questions for us.
Yeah, I can bring up the Q&A for you, Bill, as well here. Encouraging, of course, everyone to join us again on Slido for that. Just one moment, please.
Well, we don't need to go to Slido. I think Bob was just looking at the chat, or if anybody's put anything in there. I don't see anything.
No, it's just coming in. It's just coming in through Slido.
Okay, let's go through Slido. Sorry.
Yeah. So if you see anything, Steve, I'm not seeing anything at my end.
All right, folks. So if you want to, we've given the high-level overview here, a very, very 100,000-foot level. I'm sure there's lots of questions. We'll have time for some more later, but there's some initial ones. We're happy to take them right now.
There you go.
All right. Work phase planning sounds a lot like lean construction. Can you talk a little bit more about the difference? Anybody want to take that one?
I'll take that, because there there is when you get into lean, you get into the last planner. The last planner starts a little bit earlier, in the project, but at the end, you get, matter of fact, I've got a slide that's coming up. It'll be in the presentation tomorrow, where the Dan will show you the last planner, and then I show you the slide of the craft planner, and they are almost identical, guys. You're right. There's a whole lot of similarities there. Very, very little difference. Maybe the only difference is the person doing the planner. We have dedicated planners, and I think leans more on the people doing the work to do the planning. So other than that, there's not a lot of difference between the two.
Right. I'll add to that some of the history of the development of AWP kind of started in the field with work-based planning. And that started with last planner / lean constraint management by having the foreman do a lot of the constraint checking. And it kind of failed on its face because the foreman became overloaded. And that was the idea of having a work-based planner, which is a new role, who is craft aware, but separate from the foreman to help the team do planning of IWPs, which are installation work packages, which rule of thumb about a week worth of work for the crew. And so in very much similar concept, just the new idea there really was this work-based planning role, which seemed to be important on industrial projects. But let's move on here. Difference between EWP, CWP, and so on. We're going to come back to that one, but I'll take a first pass at that, which is they are complementary work packages. There's a hierarchy of a construction work package is discipline based, and it contains one or more EWPs and several IWPs. And then an SWP is a system work pack, is sort of runs in parallel to that. As you move out of bulk construction and want to start energizing your systems, you would move towards a system work package execution. They ideally are, except for the IWPs, are all developed in early planning. And we'll come back and particularly talk about some examples of CWPs and IWPs later with some more details. So I'll hold the rest of that till then. Let's move on to the next question here. Constraint free is ideal, but refinery work seems to be constraint plagued. Will there be more on this? Let me say here. Jamie, maybe you could start an answer to that.
Thank you, Bill. Yeah, it's a great point, and you're right. Refinery work can be not only constraint plagued due to materials and things that you have to deal with logistically like other projects, but also an operating environment where you may have certain items that are unpredictable that come up that you have to deal with. And what we find in AWP is that you're doing something more deliberate in terms of assigning responsibility to an individual, or maybe individuals, depending on the project size, who are a part of the planning effort to look at how you're breaking the job down into portions and packaging that, and then putting that constraint management hat on and really focusing on the management of constraint, the removal of the barriers and so forth. Sometimes what it comes down to is those constraints that arise that you're struggling to manage cause you to change the timing of actually starting the work on a particular package because it's not constraint free yet. So you may have to sometimes do some rearranging of packages due to unforeseeable issues that come up and so forth. But when you have these individuals that are really more responsible for understanding this is a manageable piece of the overall project. Now I'm responsible for the constraint management for the particular discipline, whether it's piping, whether it's other discipline work or whatever. And that's my key role is doing that constraint management. We find that you can really have better success in even being able to do the workarounds that are needed to make adjustments. There's a flexibility associated with work packaging that once you have packages, you may be able to shift to some extent because you have some that are constraint free while others aren't. And you still come out ahead by doing this planning associated with breaking the job into the work packages and doing that constraint management associated with it. Thank you.
Great. Critical path on a project change when we use AWP versus a project that's not used AWP.
I can give you a couple of war stories on that.
Go for it.
And one of the things is I notice up front is you want to understand that on some projects the owner business requirements and the priorities for commissioning and startup, and that's one of the things that's missed on a lot of conventional design build. Like I said, we design to optimize engineering and procurement, and not necessarily construction and commissioning. So when you get that commissioning requirement, what's happened in the past is you've engineered the project, you've thrown it over to a constructor, and he starts to build, and then the owner to change, hey, oh, by the way, we want to start that flare system up, or we want to start that boiler up first, and all of a sudden your critical path just starts flip-flopping all over the place trying. So what you don't want to do is introduce late things into the project after a path has been started for procurement and engineering and fabrication, and you start changing that path of construction. It will change if that construction guy and the commissioning guy are not in on the very first upfront planning, and you can support it. Your path will change and your project will go into a death spiral.
Thanks, John. I think ideally in an AWP project, your path of construction is a fairly rigorous look at your sequence from which you would derive a critical path.
Yep.
Contracting strategy. Jamie, you have an owner experience. Maybe you're a good person to take a first pass at that.
Yeah, so even in a situation where you may have, let's say, a separate engineering design contractor from a constructor, being that the EWP program, the engineering work packaging, is all about helping to ensure that you deliver engineering on time to support procurement and construction. That approach of using engineering work packaging has proven to be beneficial because it really drives the design engineers to understanding what their true delivery dates are for their drawings, specifications, vendor data associated with it, everything they need to deliver. There's clarity there. And so I've seen that work very well when the engineering contractor is when they know the timing of needing to finish their work. EWP programs bring discipline and actually a more enjoyable approach for the individual discipline engineers because they appreciate that clarity. When it comes to the construction side, that constructor being able to take the engineering work packages and dissect those into, and the CWP content as well overall, and break that into IWPs, make those constraint free. Once again, that part of the AWP program, the work-based planning part that's mainly associated with leading toward that development of constraint-free IWPs and getting those in sequence to support the construction productivity in the field, that still applies to that constructor. Now, you're having to work with those individual companies to assess their maturity and being able to apply the AWP principles and fundamentals well and get that on board. And you may not have that continuity initially if you don't yet know who your constructor may even be, but that I've seen it work. There's not an issue if you're going to have a different contracting strategy like that from a design build bid and a design bid build and be able to have AWP bring about significant benefits.
Hey, Jamie, let me jump in on that one because we run into that a lot. Our primarily contracts are design bid build. And what we do is in most cases, our owner will provide us a construction representative to help us develop that path of construction early. And if the owner does not have a qualified person, then we bring a construction representative from our organization in and we develop a path of construction. And then when we go out for bid, we qualify the bid that, look, this is the developed path of construction. So if you deviate from this, you're kind of out there on your own risk. So, but you need a construction guy up front, whether it's the owner, whether it's the actual guy who's going to do the building, or whether it's somebody within your own organization.
That's true. That design assist input from experienced construction folks is
Yep.
something that there are ways of getting that to happen, even if you don't yet know who your specific constructor will be. And it's
Right.
very important to do. It's a principle of AWP. It also gets you, of course, meaningful constructability input. That's important as well.
Yeah, the contracting issue, of course, is very important, and we're not spending a tremendous amount of time on that. But we've seen AWP work in different contracting strategies, whether it's full EPC or full design build to separate contracts to what have you. I think the clear guidance is the owner up front needs to be able to set the expectation of accomplishing an AWP and an integrated approach with early planning and make that consistent whatever contracting strategy you talk about. And we really even use the term contracting quilt because of course contracts are not just about primes. You've got suppliers, subcontractors, construction labor contractors, and so on. All of that needs to be thought about in terms of planning and making sure it moves project forward. So in John's example of you don't have a contractor on board first, okay, well, we better have the input there. And then when the package goes out, the path of construction is described. And it's assumed to be that's what you start with. Otherwise, it's starting with a new idea late in the game is not a good way to execute everything together. And so we see this as a very important role for the owner to play in a level of maturity on the owner's part for having a successful project as a thoughtful contracting strategy, however they choose to accomplish the project in the environment they work in. Project performance, cost and schedule versus budget for projects that use AWP. We'll come back to that. We'll show you some evidence here in a little bit. AWP from location-based management systems. I'm not sure I know exactly what that term means. John or Jamie, are you familiar with that?
I'm not.
I don't know either specifically. AWP certainly has a component early on in an AWP project. You're dividing the project into construction work areas typically to start to work toward your ultimate work breakdown structure of packages. So there is there's an area-based approach that drives some direction for companies that that have that background. It could relate, but I'm not sure exactly what the specific points of let's say LBMS might be.
Right. Maybe whoever asked that, come back to that at the end of the Q&A after I've done some more examples and help us out there a little bit. Where have you seen AWP done on vertical construction? I'll share one of our early cases was for a office renovation for a major owner where they were just kind of doing a floor by floor update. And this is the small contract. I think it was a few $1 million, or maybe a few $100,000 a floor, and they were doing AWP, principally the workplace planning piece there, and doing it very effectively and seeing much better performance. And perhaps the best metrics of success is the project execution team was not getting a call from the vice president every week saying what the heck's going on. So everybody was happy, basically. Most efficient size for a CWA or an IWP? Well, that's big to small. Jamie or John, do you have thoughts about how to answer that?
Well, I know that IWP is relatively, we do 1 to 2 weeks worth for a crew. And assuming you had a crew of 10 people, you're looking at somewhere between 400 and 800 labor hours there. CWAs, that can vary quite a bit depending on the type and size of project you have. And I'll give you a real good example. We had a refinery project and we had 3 units. Per se, I think it was a distillation unit. I can't remember what the 3 units names were, but anyway, we actually gave those units a CWA and assigned a different contractor to each unit because we wanted them all done simultaneously and we wanted each contractor to have a priority 1. So the CWAs can vary quite a bit. IWP, I think, is in that 1 to 2 weeks worth of work for a crew. If you get any more than that, you can't monitor it as well.
John, that's a great description. And back to that location-based management system, here's this CWA point coming up, that you do have area designations that play into how you view a overall project and start to break it ultimately into packages. And if location-based management has to do with how you might manage a project during execution in terms of certain units, then AWP works well with that concept, because you start out in that fashion by looking at the job in those units or areas, which are typically very large on a big project. Small project may have 2 construction work areas, and they may be fairly small. So it really depends on the project size, of course.
Yeah. Let's see. Supply chains are a mess. Does AWP have a great way of overcoming this?
I can answer that a little bit.
Sure.
They are a mess, and I think the real word here is mitigation and accommodation, because you need to know, we're searching what are those lead times out there. And valves are critical. There's different pieces of equipment that are very, very critical. The lead times are changing. They're not getting better. They're getting worse. So realistically, assessing what are the lead times for these things, and then prioritizing, even in your fabrication, like steel. You don't want to put all your steel in the shop at the same time. You want to say, I want you to fabricate this CWP, then that CWP. By the way, that drives fab shops crazy, but that's the way you ensure that flow of materials gets out there in the sequence that you need to support construction. So I can't solve it. It is a mess. You need to manage it, and you need to mitigate the impact of it more than anything.
Right. I'll add to that RT363, Research Team 363, just published a report looking at procurement and supply chain for AWP, and a couple of nuggets out of that. One, our orders to supply chain stink on average. Our POs are not great about providing priorities. If you don't provide priorities to your fabrication and supply chain clearly up front, how can we expect them to deliver to us the priority we want? So we found lots of opportunity just to improve how and what we're ordering with better specification. And then the other side of that, if AWP provides better orders and better priorities to the fab shops and to the supply chain, they can manage around that, provided they're included in on that early enough for them to actually leverage it. And so that early planning is shared and can be shared well. That should help the supply chain. But I like to say AWP is not a silver bullet. It's maybe a silver shovel. you got to dig yourself out of the hole, but you can work. Bob, I think you were interrupting. I know we could probably keep going for 2 hours on this. I don't know where we are on moving forward.
But let me add one thought, and that is that inside CII we have 9 CBAs, and one of them is supply chain management. They have held maybe 4 meetings over the last 3 years in conjunction with AWP, so they're very cognizant of these issues, and hopefully they'll be working more on that in the future. And I know John's been big in those sessions.
Yeah.
Go ahead.
Hey, Bob, just one more point on that one. At Bill's point about that, early engagement with the suppliers, with the key, subcontractors and so forth. I mentioned in these organizational culture aspects of AWP that if you really get a strong AWP culture within your organization, you're going to be welcoming opportunities in regards to AWP training and coordination across those different stakeholders of, potentially other owners, the various contractors, the suppliers, and that's huge. It's a significant amount of effort to really plug in those suppliers early enough on the fact that this project will be different. This time we truly are going to give you sequences and priorities. And while it may not make sense to you as an individual pipe fabricator, it makes perfect sense for the overall project for you to deliver to this sequence. And that's a huge part of what it means to be successful in managing constraints. And it means value to the project overall. And so, it's actually an enjoyable way to approach a project, because you start to sort out exactly what was described, and that is the mess that is often a part of the overall supply chain activities. I go back to a point that Jeff Ryan with Inside AWP makes every now and then. If you just look at how you're doing things currently in regards to, POs to suppliers and deliveries of things, he'll say, well, how's that working for you? And if it's not working well, AWP constraint management and sequencing, upfront work with suppliers, putting in that effort makes all the difference. Have any of us seen it work with, let's say, pipe fabrication suppliers? Yes, I've actually seen it work applying this AWP mindset. So thank you.
Okay. I think if these are the last three, let me answer the middle one there, because the other two on EWPs and CWPs are as important there. Oh, it just changed on me. So, but is AWP only for process infrastructure projects? No, we've had the most success there. We're going to show you an example when we get in there of some thinking people said, oh, how would this apply on a commercial project? So we'll come back to that. I do think a lot of the language around AWP is coming out of the industrial sector, and so there is some translation. But a lot of the principles are there, and if you're doing lean, there's probably a lot that you're already doing. I think AWP adds a process layer on top of that for consistency of execution and a few other ideas to move forward. Gosh, I can see what I thought was done has changed. Okay, there was a couple of questions around EWPs and CWPs, one here on matching to a level 3 schedule, and there was another one on right sizing EWPs to CWPs for their, John, maybe you could try to kind of talk a little bit about that, because I know you've talked through it.
And there's usually a CW in our world, a CWP will almost always match 1-to-1 for an EWP, an engineering work package. However, some of them get a little more complex, so a CWP may end up being what we call 1 or 2 or maybe even 3 releases of an EWP. I'll give you a couple of examples. In the case of piping, you've got a CWP, a construction work package, and it's kind of a boxy area. And you may want to engineer your large bore pipe and get that out to the fabricator very, very quickly so that it can be prioritized and put into production. And then you'll come back and you'll design your small bore pipe and maybe even a third one for your galvanized pipe and screwed pipe if you're gonna do anything in that realm. So an EWP is usually 1-for-1 with a CWP, but maybe split. Another example in the electrical world will be the grounding package and the electrical or lighting and was it lighting and something else package. So anyway, an EWP can be split, but it'll usually always be the same size as a CWP, if that explains things.
Yeah, I'll say around that, engineering work packages and construction work packages need to be developed upfront in parallel with input from the design team and the construction team or representative from construction. If they are not developed together and agreed together that this is an achievable goal of how we're going to make everything work, it's likely that one or more of those parties is going to be unhappy with the result as you move into execution. And so it's a joint planning process that requires upfront effort to think about how are we going to realistically accomplish a fast track design and then make sure that we're delivering design to support construction work packages in a fast track project setting. And that's hard. You know, it takes effort to do that. That's planning, that's moving a lot of effort up front. If you do it poorly, well, you live with the results of that, and that could be wrong sizing, out of sequence, over aggressive schedules for engineers, and so on. And so we're trying to take the pain that happens later during detailed design, procurement, and execute and construction, and moving some of that forward so we can have a smooth execution later. I'll stop there. I know we do want to move forward here. I think, Bob, you were talking about a break in about 15 minutes. I think some of these other things we may come back to, so let's actually move forward. I know we could probably spend another 2 hours answering questions. We'll keep these up and we'll come back time for some Q&A at the end, but I do want to make sure we're moving forward with some content here, because I think it will also help address some of the questions. So, alrighty, let me go back to show my screen. Okay, let's talk a little bit about the evidence for advanced work packaging. So what do we see for AWP? There are multiple case studies, and we're going to go through sort of our forming case studies. There's been results since what I've delivered here. These were the initial case studies that established AWP as a best practice, but we're seeing about when AWP is maturely delivered to about 25% productivity improvement, and with that a 10% decrease in total installed cost, and a whole bunch of improvements in greater schedule and cost predictability, better safety, better quality and stakeholder alignment, and improved contractor profitability, because even though productivity is improved, there also is better use of resources. And so what resources are being employed are being used and engaged profitably and productively for the project. As I mentioned a moment ago, there's no silver bullet. Achieving the benefit takes work. This is not an easy button for a project. This is a systemic way to predictably get improvements. And we have found that through cases, the initial set to validate as a best practice were 20 cases in power, oil and gas, petrochemical infrastructure, ranging from very small to billions of dollars. You can see kind of the distribution here. We had about 5 projects under 5 million, and then 6 projects over 500 million, and everything in between. Some of these were modular, some of these were stick built. And when we plotted these projects on 15 of the 20 projects that we had complete data for, we plotted maturity versus performance. This was done by expert reviews of each of those projects. So we had 4 people per project do ratings of the project, and those 60 plots there. I like to say if I was gonna fake this data, I would have made it noisier. What I've come to see is these results are from examples and cases that were very clean implementations of AWP for the maturity that the organization and project had for AWP. And perhaps the most important part of this slide is not the part on the right where you have high project performance, high maturity. It's the part where you have low maturity. You're still seeing an improvement in project performance, which means that you can get started and expect to see some gains, which is very different than a lot of innovations, because often the first time you do it, you don't see the benefit. So that's an important part. So what do we see when you're getting started? This is oftentimes you're not doing full AWP, you're doing just work-phase planning. You're getting initial champions to learn and get started, and you're seeing maybe a 10% improvement in productivity. We can see that here of around 10% in productivity, projects coming in on budget, safety is improved, schedule, predictability, and quality, little small improvements. Now, what happens when people get past their first implementation and they do a work-phase planning, which is let's just improve construction, they quickly realize there's only so much they can do because the supply chains are a mess. Engineering is not delivered in a timely manner for procurements to happen timely, and so on. And so when they move from work-phase planning to full AWP, that's where you get to be highly effective. This is where you're getting early engagement and stakeholder alignment early. This is where you get the big wins. And you're getting about 25% improvement over base. That's bringing in the total installed cost about 10% below estimates. Safety and schedule get up, and then predictability and quality also improve. And we've seen this repeated since this data set from projects that have contributed since this data was established a few years ago. And you basically, once you bring in the front end planning well and get everybody aligned, that's when you see the big wins. And then when that becomes mature, you really cement the gains. You don't have tremendous improvements, but you do see some better predictability and better quality as kind of the big jumps at this point. And you're maintaining the benefits elsewhere in terms of safety, productivity, cost, and schedule. So this has been repeated multiple times now across projects. We've seen of productivity improvements above 25%, but that appears to be, very achievable to get when you do a workface planning implementation on site, which you could say is very much equivalent to a last planner type of constraint management, and you align the front end with the back end with full AWP. And so this is the level we get to, and sometimes we'll see people saying, I want all the benefits in my first implementation. Well, that may not be achievable, but we do think early implementations do have some significant benefit, and as you get better at it, you cement and mature and keep those benefits across all your projects. And so where we see is a lot of organizations now are trying to make AWP their baseline for every project. It's not just the one-offs. It's as they get maturity, well, we want every project to be this way, and it becomes the way of working. So how does AWP work? Let me click through this pretty quickly, and then Bob, we can assess if that makes sense for a break. So AWP is very process focused, and I've shown some process charts to one of my architect friends, and she's like, ew, no, that we don't think that way. And so I'm not going to show you process charts. I'm going to show you pictures of outcomes of what does it look like. So let's show a plant first. This is a big industrial process plant. You have a overall project. You're going to break that into large chunks of work called construction work areas. It could be units, it could be areas. This is an optional construct. It's on a big plant or a big project, you might want construction work areas, and a smaller one, you might not need it. But the construction work area is an area, and that is broken then into CWPs and EWPs, and then we have templates for them in our documentation. The key thing here is not the template, but the CWP and EWP are the official ways we think about breaking a project into its pieces and how we transfer information. And that is area and discipline based. And so that's different than saying, here's a complete set of plans for the structure. It's no, this is the complete set of plans for this construction work package in this area and per discipline, which is composed of one or more EWPs. So here is a construction work package within that larger CWA. It's still a big body of work. It's some complex piping. And it's, in this case, it's a piping discipline only. So it's CWPs are per discipline. You would have a structural discipline. You'd have a foundations discipline, CWPs, all within the CWA. Notice the tie-in point called off there. That may not be a functional valve in the final plant, but we're adding something there to allow the CWP to be complete and tested amongst its constituent parts during construction. So in engineering work packages are lined with the physical boundaries of a CWP, and here in this case we're showing the CWP is broken into two EWPs. John Fish mentioned that in his work it's often one-to-one. Many people will do that for execution, but it doesn't necessarily need to be that way. The hierarchy is one CWP contains more than one or more EWPs. And that alignment first has to be within the boundaries. And the reason we want to make sure those EWPs sit within the boundary of a CWP is because we have a plan of how we're going to procure and build this CWP in the field. And we want to get the complete set of EWP information, which would include all the pipes and the sizing and the valves, but also the hangers and all the detail work that would come later. Typically, we want to get that done and make sure it's delivered in a timely manner. So what does that mean? Well, the process engineer for this pipe still has to deliver or still designing by system. So they're going to do the complete system design for the pipe. But when they think about prioritizing the detailing, they're going to deliver that by area or within the CWP. So that will change some of the detail work that the engineer does in the sequence for that. I remember talking to a structural engineering lead from Floor back when we were discussing this, and he said, you know, you often don't tell me as an engineer what you want first, so I'm going to do what's most appropriate for me. If you tell me what you want, I probably can deliver it. Just make sure you tell me early enough to make that work. And that really goes back to the EWP and CWP planning needs to be done effectively early on to make sure it's realistic for everybody. So once we have the CWP informationally complete in terms of its engineering work packages, all the design is complete, and we've gone out and procured it, we can break things into an installation work package. And that's this IWP here, which is roughly a week's worth of work for a crew. Rules of thumb, 500 to 1,000 hours. It's really what makes sense. It needs to be something discrete and manageable that you can process constraints on, make sure all the parts are available, all the equipment's available, safety checks have been done, etc. come in here. And then you do your installation work pack to put this together. The crew and the foreman still has great choice within this IWP of how they're going to assemble within that. So we're not removing all responsibility from the foreman, but what we are doing is having a workface planner that helps assemble these IWPs. And best practice is to keep the IWP definition virtual for as long as you can and only release physical paper to the field as late as possible so that you can, if you can move things around within IWPs within the CWP. If a valve is missing, we'll move that out to another plant or to another IWP, but make sure that you're releasing logical sequence of work and to the field for the crew to be productive in the field for this time. So there was a question, I saw it popped up previously about what about test packages? Well, your IWPs, you could also have an IWP for a test pack. What you do want to do is once you're finished a set of IWPs and it's logically correct and complete, and you've done the hydro testing on the EWP, in this case for piping or whatever other limited commissioning, at some point though, you're going to move to an SWP, which is a system work package when you look at energization and other aspects of commissioning to final turnover to the building. So some people will use the term test work packs. Many will use that as an addition to IWP. That was one of the questions I saw there. All right, and so how does this work for a non-process plant? Well, a couple of years ago, a team had said, okay, how this might work for a location where there was a venue, commercial Jersey Shores Hudson, there was a meeting there. So well, let's talk about how we break this into an AWP approach. Well, so here's this retail complex, there's an amusement pier, there's a hotel. Well, let's break it into some construction work areas. We're going to have some things that when things are to be completed in 2016 through 2017. Do the retail dining complex first, the hotel to follow, and the pier to follow that. Okay, so these are the CWAs. Now within a CWA, you will have multiple construction work packages for each discipline. You might have one for underground piling, that's the full CWA. You might break your foundations into smaller chunks within the CWA, in this case 4, and you'll have framing, other 4 CWPs just for building framing within the CWA. Each CWP can have one or more work packages. So for foundations, you might have 3 EWPs that talk about foundations for CWP1, similarly for framing. And then to kind of think about how this all comes together here, you can have some CWPs and EWPs within those CWPs. The key thought there is you're keeping things together per discipline, so that also directly supports procurement. And then finally, once all the design is complete and you're ready to release to the field, you can have a series of IWPs. You might have one for a couple for footing and formwork. You might have some for reinforcement. You may have another one for the concrete and formwork, and so on. And then they would all come together in alignment like this, where you have a set of CWPs. A CWP can contain one or more EWPs as makes sense. And then once the CWP is informationally complete with design information, that CWP is broken out into multiple IWPs releasing to work into the field. Rule of thumb in industrial projects, about a week's worth of work for the crew, but that's use your judgment. The key thing, it needs to be small enough to be trackable and constraint managed against materials on their availability for resources, but not too small to get into, hourly planning. That would be a different thing entirely. Occasionally you might need a project that gets down to that level, but that would be very specific. So with that, I think that is a good break for us. Bob, what do you think?
Yes, I think that's a good place for a break. Just a reminder that people can enter their questions during break. And we're going to take a 30-minute break. We might come back just a little bit sooner than that. Maybe you want to make it 20 in order to make up for time,
Sure.
Bill?
Sure.
So let's make that a 20-minute break. So we'll come back at about 5 after the top of the hour.
Okay. See you all
Thank
then.
you, everybody. Welcome back, everyone. And we'll start again here, and I'll turn it over to Bill. You're on mute, Bill.
Here we go. Welcome back, everybody. I believe John Fish is going to take us through a workface planning example. John, I believe you have control of the slides.
Okay, I'll take over. Whoops, went too far. Went too far again. This technology is something else, isn't it? Trying to get back up to the first slide.
See if I can help you.
And just a quick tip, John, Steve
Yeah.
here.
There you go. Okay,
Okay, perfect.
got it. This Fernando Esparza and Lloyd Rankin developed a puzzle exercise that they use at the ConstructX University, or it was AWP University training. And I thought it was a really good exercise to explain the differences between conventional, construction methodology and the AWP methodology. Even though we can't do a hands-on, I mean, at the university, they actually get one group and they will construct a puzzle using conventional, and then they'll get another group and they'll construct a puzzle using the AWP methodology, and then they'll compare the results of the two and talk about the differences. So even though we can't do hands-on, I've tried to summarize this particular exercise. So let's go through it this way. Trying to get those slides to come down. Okay, conventional. When you build a conventional puzzle builder, and I hate to admit the fact that I am a puzzle builder, by the way, I've been addicted to puzzles for quite a while, but you usually start with the corners, and then you do the border, and then you start filling in all the middle section. So if you're looking at conventional path and construction, you're really looking to build the easy stuff. The corners come first, the border, then you fill in the more middle, and you build what pretty much is available. So first step is we're going to set the corners. So this is just an illustration that said we put the corners in place. By the way, they did deliver pallets of corners and borders to us, so we got that figured out. Now we start building the border. A little bit of trial and effort here, but usually you can get a border put together, fairly easy. Takes a couple of tries, but you'll get it eventually. So Let's go on to the next slide. So now we got the border pretty well done. Now we got the middle, and this is where life gets difficult. And by the way, I've got a Cuddy Sark ship model, and I'm still struggling with these middle pieces. It's very, very difficult. But anyway, this is the hard part right here, trying to shake out. You're going to build pretty much what's available. So there's a lot of rework. There's a lot of guessing here, trial and error, see what fits, what doesn't fit. I'm missing this, I'm missing that, and so forth. So next one comes up here, hoping. So wrong, please. See, I got to fix that. So celebrate. Eventually, I get it done. So I get my puzzle built, and the average time that they've been clocking for those people is between 6-7 minutes, something like that, to complete. So let's look at the AWP methodology. Oh, by the way, there's a lot of variations and approaches and a lot of rework because you have to try things and they don't fit and you move them around a little bit. So let's go to the AWP. So in the AWP principle, we look at a sequential flow of information and materials to the site. So here's where your field planner, they're going to prepare that constraint-free installation work packages that we talked about. And we're going to bag and tag all the materials. Now, not only that, but the field planner is going to make easy to read what I call assembly or installation instructions, not just drawings, but he's going to take model shots in many cases of that model and annotate those model shots as a step 1 or a piece 2 or a piece 34 or a spool, 57. So he's going to give you directional errors, number the pieces, and he's going to give you really clear instructions on how to install that work package. And it's going to be the same way with our puzzle. So we got all these little different pieces. We're going to follow that path of construction we talked about. Notice we're not going to start building the corners. Doing the easy stuff doesn't necessarily give you a competitive advantage. It looks good, but it doesn't necessarily mean you're going to finish any quicker. In some cases, it can even hurt you. So we're going to start at the bottom left and we're going to work to the right. Notice all these pieces are numbered. The bottom row was bagged and tagged and the pieces are numbered. I mean, you can't miss here. So then the next row, following the numbers again, 10, 11, 12, and fit those right on top of the others. Now, we may even want to do a little bit of pre-assembly, put a few pieces together and then move them in as a chunk, and that's okay. You're going to do the same thing at the job site. Little pre-assembly, might get a jump on things, make it easier to get things to fit together. So anyway, when we finish, notice 1, 2, 3, every piece is numbered with explicit instructions. The average time is 2 to 3 minutes versus that 6 to 7 minutes we talked. And the main thing is almost zero rework using the AWP constraint-free methodology. And what I want to point out is that rework is unplanned work. Unplanned work is not scheduled. The more rework you have, the more impact you're going to have on that schedule. Each time you have rework, you're going to build up that negative schedule impact, negative productivity, and that's where the killer is at the job site. So the A in AWP, it's all about the planning, guys. I mean, come on. You're going to do all that preparation planning up front so that the guy in the field, the craft, you're trying to make that craft productive. That's where we're going to spend our money. Rework and misfits and looking for stuff and waiting for stuff. That's where your money goes at the job site. So again, that construction defines that path of construction. You're going to align the stakeholder to support it. You're going to have that structured process, the consistent education. Your planners are going to keep the foreman, they're going to do all the major planning for you, rounding up all those materials, rounding up all those information, and they're actually going to number those pieces and build explicit instructions for you so that you can prepare that constraint-free work package for the craft. Making the craft productive is what it's all about. So thanks again to ConstructX for sharing the puzzle game with us. I think it's a beautiful illustration of the two different concepts. So now I'm going to turn it over to Bill. Do I give it back to you or Jamie?
I think you can just keep going if you guys are still on deck.
I think Jamie's the next slide. It's not going forward for me for some reason. Jamie, take over.
Very good. Okay, so, Bill showed earlier the research results indicating what the expectations could be around improvement across performance dimensions when a project implements AWP. Well, some 5 to 6 years after that main body of research from CII's Research Team 272 published their implementation resource, we went to a cross-section of owners and EPC companies to ask for their feedback on actual experience with implementing AWP fundamentals relative to what we were seeing in improvement across these performance dimensions. And I just want to share some of this with you in terms of now this is actual data, not just from the case studies that supported the research results, but projects that picked up on what AWP was about as a result of that research, started implementing, and how things turned out. Now, keep in mind, as Bill shared, the general expectations around improvement, let's say in productivity, were that when you're at a initial stages, the early stages of maturity in the organizations that are a part of your project team that are implementing AWP on a project, you might see a productivity improvement in the range of, let's say, 10%. By the time you get to that middle level of maturity, you've moved it more toward as much as a 25%. And this also corresponds to the fact that you could see as much as a 10% improvement in cost along the way. And so I want to just share quickly through this. You can see how it's broken down. The first 2 pages represent a return on investment benefits from owners. And this is, again, a cross-section of a number of owners who've been active in the AWP implementation community. Their perspective on what kind of benefits they're seeing. So first of all, you'll see safety, then you'll see quality, then cost and schedule listed. And this is just across a number of projects of various sizes and complexities. First of all, under safety, we had an owner report that they were seeing as a result of AWP implementation, outstanding safety performance, TRIR of 0. The next one, 0 recorded lost time. Third, better safety compared to previous projects that were not implementing AWP fundamentals in particular. The next one, field supervision and workforce were easily visualizing the work via model shots that were included in those IWPs. Keep in mind that for any of these work packages, the intent is not to overstuff them with information, but to have the right information that the field needs in an IWP to be able to perform their work safely and productively. The next point, having the IWPs enable discipline team to perform their hazard analysis with the execution team by the IWPs and to make informed, timely decisions. We haven't really brought this up in particular, but let me mention that one of the things AWP obviously does for you is that it helps to elevate issues and vulnerabilities associated with your project at the right time, or at, let's say, an earlier time than those things might typically come up, so that you can deal with them. And that's just as a part of the fact that you're coming up with an aligned path of construction that you're working to. You're putting on that constraint management hat along the way. And again, you see a culture that helps bring that teamwork approach that's very important. Under quality, here's an owner reporting stellar quality performance with rework mainly occurring in those cases where at this low maturity level with AWP, they may have had some IWPs where the field personnel were not able to fully follow the IWP and got outside of that a bit. Another one, rework less than 1%. Next, quality inspections increased. You might expect that they would increase to the appropriate level, because IWP should have a closeout process that includes performing the right level of quality checks at the right times before you do so much work that you might later find a problem that's going to give you a much bigger issue to deal with further down the road. Next one, significant reduction in RFIs. And then the next one, extremely low number of engineering design changes, which can come about because in AWP, you're really driving engineering to deliver their finished product on time and to limit the amount of change that would ultimately take place. Cost and schedule. How about this? 11% cost underrun versus total project expenditure. The next one, greater than 10% total installed cost underrun versus the original authorization. you'll see that these numbers are right in line with what you would expect in those early to mid levels of implementation of AWP fundamentals on a project. The next one, final cost significantly below appropriation. Next, completed ahead of schedule and under cost. Next couple give some specific numbers. 6 months ahead of forecasted schedule. Project delivered 3 months ahead. The last one on this page is interesting because it points out how a project could see that they did not have constraint-free work to issue at the time that they initially intended to start the work on this pipe installation. So they delayed the installation by 3 months. Then they became constraint-free as materials were delivered and they could have those IWPs ready to issue. They avoided the costs of having pre-mobilized too soon, and they recovered the schedule ultimately in 4 months due to the productivity gain. So very positive. We could go to the next page. So now on the productivity, also from the owner perspective. How about the first one? 25% improvement in field productivity compared to similar projects. Next one, clear productivity metrics improvement where AWP was applied. In piping, almost 20% improved, similar in electrical, and then steel installation didn't have quite as much of an improvement, but understandable. The third one, manpower efficiency increase of 12%. Next, productivity, 10% better than planned. So you can look down this list, go down a few more, and you'll see hands-on tool time observed as best in class. Then time on tools for steel and pipe erection of 70% and 63% respectively, versus some industry average data that showed more like 37%. And then next, effective constraint management with timely decision making. This gets right back to that point about how when you're doing active, taking responsibility for constraint management, doing active constraint management, you find that issues get raised at the right time and decisions can be made appropriately to deal with those. Materials on site to support the construction sequence. And then the next one, second from last, limited nights, weekends, and overtime work. Overall, just very positive feedback in terms of what the AWP fundamentals being implemented were meaning to owners in actual project applications. And then last, these are pretty important as these others. Interface challenges identified in engineering before hitting construction, streamline turnovers for mechanical completion. Here's one about software automated, repeatable tasks, bringing about efficiency and consistency. So the bigger the project, the more the automation tools and information management tools can enter in and become a part of helping to enhance the overall implementation and results. So let's go on to the next page. And now we're going to take a quick look at what the EPCs were reporting at that same time. This is from a cross-section of EPC companies that have been working with AWP implementation. First of all, in safety, reduction in safety incidents. Next, reduce HSE exposure hours. That's very important. If we can get productivity to improve, then we're exposing the workers potentially to less time in the field actually performing work where they have the potential to be exposed to hazards. And quality, reduction in NCRs up to 50%, and reduction in punch list items. How about this? Up to a 95% reduction. Then cost and schedule, potentially some increase in engineering costs as a small percent of the total installed cost, but ultimately also procurement services, you see a very small percent of total installed cost increase there, but the reduction in construction costs of over 11% overall. So you're offsetting what may be minor increases in engineering and procurement associated with the discipline that you're applying in AWP. The fourth point, up to 15 to 18% improved cost performance on direct hire projects through use of AWP. And you could go on and on down this list of fewer labor hours, fewer associated indirects, and so forth. And now let's go to the last page on this section here. This is a continuation of a few points from the EPCs. What were they seeing as they applied AWP fundamentals? First of all, in productivity and hands-on tool time, the creation of IWPs is having a significant positive impact in field level productivity. The next one, up to a 25% increase in productivity of some crafts. And then under other, alignment in scope, communication within the project team, subcontractors, and owners, that alignment was taking place in a better way than it had in the past. And then some EPCs are looking at this as a positive step in a direction of showing owners how well they could execute efficiently using AWP, which has the potential to impact the future work with the owners. So this is intended to show, here's more of an up-to-date view of just what the actual experience has been, shared by owners and by EPCs, and it's very much in line with what the expectations were that the research team that Bill worked with within CII put together, some 5 to 6 years later in publication, forecasting what sort of improvements AWP should be able to bring. So that's good for now. Thank you. John?
Thanks, Jamie. Okay, I assume I've got control of this. It doesn't seem to be going to the next slide. Try it again. There we go. Okay. There's when we Ford Bacon Davis, when we first started this, I want to warn you guys that there are implementation issues when you go into AWP. There's a lot of things you got to look at. One of the first things is not even on this list, and that's consistency. We had to develop some project management steps to AWP to ensure that all of our project managers were approaching projects the same step 1, step 2, step 3 manner, in a consistent manner, in a way that we can improve the process. But one of the first things we ran into, and I talk about, we do a lot of revamp projects. Our projects are anywhere from $1 million to $300 million and everywhere in between. And a whole bunch of them are in the $10 million or $5 million and less TIC range. And we just got a bunch of those things, coming and going all the time, 30 or 40 of those projects, in some form or fashion being executed. So the first thing we had was the scalable challenge. How do you apply AWP to the smaller projects? And we'll talk about that a little bit. And then we look at revamp and renovation versus new construction. There are some differences. It's just, think of a highway. You can't just go out and work on it. You can't just go down and shut the freeway down and start working on the doggone thing. You got to build contraflow. You got to put up barriers. You got to make lanes narrower or jog them over. There's all kinds of things you have to do in a revamp or renovation project to protect people and keep things moving and keep a plant in operation. There's safety issues. There's just all kind of things you have to consider. And then we get into conventions, and conventions is getting the discipline. This is where you get into the data management, by the way, data integrity, how do you manage the data? But conventions have to be established, they have to be adhered to, and they have to be consistent, in order to utilize, especially on your larger projects, the automation that you're going to need to execute effectively. And data integrity is really, really key. We'll talk a little bit about data integrity. And then comes the big guy, the AWP compliant model. What does an AWP compliant model mean? And I'm not real sure that's been fully defined yet. So let's explore the issues here. The first one is going to be the scalable challenge. Keep hitting my little thing and it doesn't seem to go down. Not going, oh, there it is. Okay. This is a chart that we made up here. We have what we call 4 categories of projects. I'm going to start with category D, the major project, the $200, $300 million. Whoops, it went all the way over on me. Not sure what that's doing. How do I get it back, Stephen? Are you there? There you go. Okay. So let's start with category D is the major project, multidiscipline. We're going to use every tool automation we have on this thing. And believe me, we have developed an elaborate set of automated tools to manage these kind of projects, including an AWP compliant engineering model that feeds all the way out into construction. Now you got the little bitty category A. These are the little bitty dinky projects. You could probably manage these things with a number 2 pencil and a Big Chief tablet. So you got to be real careful here. How much AWP are we going to do? But no matter the size of the project, we're going to approach it from the standpoint of how am I going to build this thing? I don't care how small it is. I've got to approach it with constructability and the sequence in mind. And then you have your 2 categories in between. Category B It's a small project, multi-discipline. Okay, it's going to be third-party construction, and I may not use a construction model on this type of a project. May or may not use, but you got to use your head here. You want to do what's smart. Don't force fit anything. Then a category C, yeah, I'm probably going to use IPM's construction model for the contractor, but I may not use my full tool set, such as a controlled warehouse and trial allocation and some of the other tools that are in our chest. So just like any carpentry project or home thing, you got a full set of tools to work with. The trick is, how do you apply the tools in an effective manner to the size and type of project that you have? So scalability is a really big issue here. Let's go to the next one. Thought I got it to the next one. Okay, now we got, whoops, I keep going back too far. Okay, the next one is the AWP conventions. There's a time delay on this thing. So these are some of the conventions that we develop. Now there's all kinds of conventions. It doesn't really make any difference what your conventions look like, as long as you have a set of logical conventions in order to manage data. I think time and time they said information management. How do you manage the data? Data integrity. This becomes extremely important as we move forward into AWP in order to gain the benefits, of automation. So we start out with a typical CWA is 600, an EWA or EWAs. I almost didn't want to put that term in here. That's really a CWP and EWP be 603. So that'd be a subset. There may be a 601, 2, and 3 in this 600 area. Notice we have a phase. Our phase PT means pre-turnaround work, because in this particular project is revamp. I have to do some early tie-ins. I've got to do a demo package. I got to do some pre-turnaround work. Then I have to do some turnaround work, and then I have to do some post-turnaround work. So my one project, in effect, got broken into 4 or 5 different projects, because I may have a different contractor doing the demo. I may have a maintenance guy doing the early tie-ins. I may have one contractor doing the pre-turnaround work on some kind of a contract. He gets it all done and he leaves, and then during the turnaround they bring in another contractor to do the turnaround work. So I have to, not only do I have to look at 603, but I got to look at the 603 area work for demo, the 603 area work for pre-turnaround, the 603 area for turnaround work, and then 603 for post-turnaround work. So life starts to get a little complicated here on a revamp project. Then I have the P. The P just stands for piping. Then I have the EWP, and that means EWP 01, 603, pre-turnaround piping package 01. As Bill stated, I could have an 02, I can have an 03, I could have an 04, depending on the amount of piping that's in that particular work package. Then you've got an IWP, and then we have a line, an ISO, and a spool. So I'm not going to get into detail here, but notice how these cascade, and with our automation, we can pull these things up, we can sort them, we can do all kinds of things if we follow the conventions. So the message here is you need conventions. Naming conventions need to be consistent across all projects, and they need the disciplines really need to be working with each other to ensure that their conventions will support that field planner in the field. Remember, everything we're doing here, our whole job is to make it easy for that field planner, to make it easy for the craft, so that they can increase the productivity on this project and execute in a predictable and a safe manner. So let's go down one more. I do have trouble with these slides. Okay, whoops, went down again too far. Go back one. All right, these are the discipline standards. These are what we call the model naming conventions that our disciplines came up with. And I'm not going to go into detail on this, but it's very much like those conventions that I established. Our disciplines have come up with how they name all of their models and how they put them all together so that we can sort and select data out of there. Then we have what we call an AWP compliance 3D model audit. And these are all of the things here that we feel are required in order to have an AWP 3D model that will support a field planner. And you go down here and you mark the things, yes or no, that we're going to do. And you do this very early in the project so that the design team knows that, hey, they've got to put the time up front to make these things happen. And now the reason we have this little audit sheet is it's kind of a commitment thing for one. On most projects, there had better be yeses in everything. That's what my office manager wants to see. However, there are some of the smaller scalable projects that we talked about where it really doesn't make sense to do some of these things. In that case, the project manager and the disciplines would get together and they would mark those a no. Now, in order for that to fly, that project manager has to go to my office manager and explain to him why it's not a really good idea to do that on this project. It just doesn't make sense. As long as he can convince our office manager, he's fine. But the principle is almost every one of these things is going to be a yes on most of our significant size projects. And this is a commitment thing. I don't want anybody to come up and say they didn't know. Hey, you filled out the audit sheet. This isn't part of your estimate. You should have allocated the time to do these things. Next slide. Tag integrity. I cannot overemphasize tag integrity. If you have a tag, a CV-101, that thing needs to be CV-101 on the P&ID, on your control list, your instrument index, on your purchase order, in your 3D model, on your ISOs and your drawings. Because we're going to do, or at least we try and do with our automated systems, trial allocation. And what trial allocation means is a field planner will look at that model and he will pick certain aspects of that model. He'll pick some piping, he'll pick some instruments, he'll pick some valves, and it'll come up and it'll say, okay, here are the valves you're going to need for that IWP. Here's the spools you need for that IWP. Here are the valves you need for that IWP. It will actually run over to our warehouse and say, are these things here? Or will they be here in time to support this installation work package? If the answer is yes, then he can bundle that thing up and send it over to the general foreman and the superintendent for the additional planning, and he can wrap up that package. If the answer is no, then he has to select some other materials. But if that purchase order, if the P&ID or the drawing has a CV-101 and the purchase order has a CV-101, it can't find it. It just goes into a black hole. So that's one of the biggest problems we have is getting tag integrity. And I'll tell you a story right now. There is a major refinery that is in the process of going up for sale. Well, what they did, they looked at that, I think they got something like 12 units, and they looked at their first unit and they said, let's do a data integrity check and see how all of our data in our document management system, in our warehouse, and so spare parts, in our control list, all the different things and the drawings, and let's see how things match. And out of one unit alone, they came up with 9,000 tag issues, orphans. Tags that didn't match or were inconsistent. So now they are spending a fortune going back on data integrity, trying to match all of these things up. The same thing will happen on a major project. If you don't have tag integrity, you've really got problems. Now we've developed some really slick routines that really runs out an overnight check, and we do it on a weekly basis. Usually we do a tag integrity check on a weekly basis. We scan the POs, we scan the P&IDs, we scan the control list, we scan the drawings, and we look for orphans. And that way a squad leader can fix them, fairly, very quickly. But I can't overemphasize the importance of tag integrity and data consistency. A lot of people call it tag integrity. Either way you look at it, it must be the same. Okay, so the next one, this is the big guy right here, an AWP compliant model. What in the world does that mean? And I don't think there is an official definition. We came up with one because, and I'll tell you the story. This was years ago. We designed a project, and it was one of those low bid projects, hurry up, get it out. It went to the low bid engineering. And so we hurried up and designed this thing. And then guess what? They ran out of money, so they put it on hold for a year. And then they brought it back out, dusted it off, said, okay, we need it. We need it in 2 months. So we hurried up and got it all out. They got the model done, and they sent the model out, and they went out for the construction, lump sum price. And one of the contractors come back and said, we're going to do this AWP, and we're going to save you guys a lot of money. We're going to demonstrate how good we are at AWP construction. Well, that was a line of bull, because in the first place, they weren't here when we engineered the thing. So the A is not in the AWP. The best they can do is work package, what's there. But they could not do the advanced planning. So then they dug into the model, and they come back and ask us, is the model complete? Well, yeah, our model's complete. Everything is there. Now, at those days, we couldn't spell AWP, just to make it very, very clear. So anyway, the constructor started looking at the model and said, whoa, wait a minute. We bid this thing on an AWP compliant model that everything was there that we needed for our field planner to package this work. We didn't have spool numbers in there. We didn't have field wells in there. We didn't have piece marks in there. We didn't even have the CWA, borders in there. So, none of the AWP requirements were in that model. They came back and said, and this was $130 million TIC project, and they wanted an additional $350,000 adder to go back and make that model AWP compliant to support their field planner. So we learned a big lesson on this. So from that point on, our office manager said FB&E will produce AWP compliant engineering models. So the next challenge was, what does that mean? This is our definition of what an AWP compliant means. It means that our models are going to be labeled by CWP phase and discipline. All of our lines will be labeled by CWP phase and line number. ISOs labeled by, spools labeled by, field wells are going to be visible. You look at most of your 3D packages today, you don't have no idea where that field well is. It's a little bitty X that's hidden underneath that pipe. It's there, but you can't see it. So we had to go back and do a lot of revision to our 3D modeling packages to make our wedding bands available and give it a unique number, because we got to track those on the well track program. Steel structures will all be of a tag. We never tagged the steel structure before. We didn't tag our foundations before. So there's a lot of things here that have to go in to make what we call an AWP compliant model, with the goal of making it easy for the field planner to assemble those installation work packages with the part numbers and the piece numbers and the flow arrows, just like on that puzzle. And that's the important thing. That's what you're trying to do. So that pretty much takes it from me. These are some of the challenges we had implementing AWP. I'm sure you're going to run into some of these too. Good luck on your journey. I'm going to turn this back over to you, Bill.
All right. Thanks, John. I sure, reflecting on this, it looks like a lot, but this is really why you do the planning up front. All of this is a lot easier to accomplish if you agree how you're going to break the project apart early on and have in place a nomenclature and a work breakdown structure that's consistent with your AWP execution model by CWP and EWP.
Yeah.
If you have that, all this becomes a lot easier to implement. It's hard to engineer this later. Although everything here needs to be done at some level to get it out in the field, you need to track it and find it. And if you don't have the plan in place, you pay for it in the field.
I'm going to short circuit a question here, because somebody's going to ask me, won't this add a lot of money to your engineering? And you could not believe the squeals from our engineering people when we started this. They said, oh man, you're going to double the budgets. It's going to take this, it's going to take that. Once these things got established, and once they used on the third, by the time we did the third project, hey, you got to call these things something. Why not call them by the conventions? And it just came out really, really easy. It does not add anything to the engineering. It just means that you have to be more careful with your data integrity. That's the key.
You're moving the planning up front. And
Yeah.
we had a question earlier about location-based methods. And I want to come back to that. And I'd sort of seen that before. I wasn't sure. I took at the break and looked at that. And that's really blending classic last planner constraint management with line of balance type methods.
Okay.
And that may be an oversimplification, but yeah, our IWP process is exactly that. You may choose to use line of balance. You might use a short interval schedule, but you're going to break your project apart by area and by CWP into smaller IWPs, which is locations, to actually accomplish the work. And where AWP adds something new to that is really two things. One, we have this concept of a work phase planner, which is an ally to help the field accomplish its planning well. And that then gives more time for the foreman to spend time with their crew in the field, which we know is important because foreman skills are not what they used to be and crew skills are not what they used to be. So getting more time for the foreman to be out with the field and in the field with the crew is actually better for everybody, for safety, productivity, quality, and so on.
Right.
The other piece of that that's a real innovation for AWP is exactly what John is showing here, is you have a plan and nomenclature in place for your work breakdown structure, your control structure, your execution planning that aligns your engineering, procurement, and construction efforts into areas and work packages that then are arranged hierarchically to get things to the field in a productive manner that supports effective constraint management. That's really what AWP is about. And we're very process centric because we want to do that well on every single job. And the organizations that have adopted that as part of their corporate execution strategy are finding success. It's hard to get started, but once you get there, they're finding it's the everyday thing. And that's, to me, is really where AWP has things to offer to the lean community, is this, the currency of work packages and the process discipline of doing it every project, in a repeatable and reliable way. So I think if we move from here, we were having a couple of golden nuggets from Jamie, and then I think we were going to go on some Q&A. So Jamie?
Okay, so we have these golden nuggets we want to go through, and really, golden nuggets can come from all participants in terms of what are the main takeaways from the information that's been presented. And I want to just offer a few thoughts here that we put together. First, that AWP's demonstrated payoff includes improved safety. There's 25% productivity increase, 10% total installed cost reduction, greater schedule and cost predictability, while also benefiting from an enhanced organizational culture. The next point, work packaging breakdown structure provides an organized, consistent, as John mentioned, a manageable approach to planning and execution of engineering, procurement, construction, and commissioning and startup. We go to the next page, Bill. Yep. With its alignment of stakeholders, the path of construction development and work-based planning, AWP delivers sequenced, constraint-free field work packages that support field crew safety and productivity. Is it easy? No. It takes effort, it takes work, but it's worth it. The next point, AWP applies across sectors, and it is scalable to project size and complexity. And then the next point, AWP areas for improvement, data technology enhancement opportunities, and implementation difficulties are being addressed, and that's through various efforts. For example, the activities of the Community for Business Advancement, the CBA, and the deliverables that have been produced by the CBA and continue to be produced. This AWP plus Lean joint working group that we have been talking about and that a number of us are members of. The body of knowledge development for AWP, which is another effort that's taken place through the CBA. And the AWP concierge, which exists. It came from one of the research teams over the past couple of years, and it's in place as a CII resource to help companies, owners, EPCs, constructors, as they are implementing AWP. And as John mentioned, you know, there are challenges, there are barriers, there are the cultural aspects to work with. And this concierge offers ways to address and overcome these various barriers. And then further research support continues, and there are opportunities as we go forward. You know, as just kind of from my perspective, sort of a closing thought from my perspective, you know, Bill mentioned just a minute ago that with AWP, you're moving the effective planning more toward the front. And in conferences and in gatherings of project practitioners in the past years, where I've had the opportunity to ask participants for a one-word answer to a question around what is our main area for improvement as an industry for that group. And, you know, typically safety will be one point that will be mentioned. Cost will come up. Efficiency will come up. But as that group continues to bring all of those points up, they all point toward more effective planning. So planning becomes the key word. And there's no question that AWP addresses that challenge of the need to do the appropriate, effective planning for projects to lead to the improvements that we've described already. You know, back to that organizational culture of AWP. From my experience, after project managers, construction managers, superintendents, general foremen, and crew members have the opportunity to work on a project that is truly implementing AWP fundamentals. They're not just saying that they're doing it and they're just halfway implementing, but they're truly getting it. Those individuals want to once again do AWP on their next project and their next project and all the future projects that they will have the opportunity to work on. So I think that speaks well for what it means to individuals on a project team when they have an opportunity to really be a part of that organizational culture and experience. Thank you, Bill.
Great, thank you. So we have some resources that are available to you. There's the knowledge base on advanced work packaging with CII, and Group ASI, our host for the conference, also has a set of resources. Now, I think we're going to I think we basically effectively did our closing comments, and let's go into our Q&A session here.
Yeah, Bill, I have access to some of the questions, and we have a few that have been ranked here with several people asking them. How do you implement AWP not having an EPCM contractor, but different EP and C contractors?
I think I tried to touch on that before, but you either, if it's a design, bid, build, and you're not going to have that construction contractor on until later, you've got to provide some type of construction guidance or planning. And whether that is an owner representing a construction person, or whether it's from your own organization. In our case, if the owner cannot provide a construction representative to plan that project, develop that path of construction, we'll bring one of our construction managers into the engineering sector, and he'll actually act as if he was the guy who's going to build it. He'll come up with the best plan that he thinks will meet the owner's needs and consistency. We will develop that path of construction, and when it goes out for design, it goes out for bids, we have to make it very clear that, hey, that is the path of construction that this project is based on, and if you deviate from that path of construction, you could very well jeopardize your flow of information and materials to the job site.
Hey, John, let me add that.
Go ahead.
Yeah, let me add real quick. You know, your decisions around your actual contracting strategy have the opportunity to be influenced by your desire, your intent to apply advanced work packaging. So if you can tell for your particular project that you know you are going to apply AWP on, would benefit from everything you're seeing with more of an EPCM approach versus an EP and separate C arrangement, then let that be one of the key considerations that are a part of what you put into the decision making on what will your contracting strategy be. But it does work across various contracting models. Thank you.
To make things even worse, you have an E by engineering company, you have a P by the owner, and the C by a constructor. Getting those three together is even more challenging.
Kind of a follow-up here that just came in. Can you please outline the typical contents of, in other words, document information types of EWP, CWP, IWP, SWP, and who leads the creation of each?
I think those are covered by your documentation, aren't they, Bill, the CII publications?
Yeah. I think the key point really is that you want to get the boundary definition of what goes in the containers done in early planning so you can execute later. And so filling in the containers, done by the functional area, that's the designer or what have you. But the plan for how those packages coordinate needs to be done well in planning before you dive into detailed design and procurement. Otherwise, it's almost a recipe for disaster. And then there's a related question I see as a minimum content for EWPs and so on. There are some templates that are available in RT 272 in the documentation there of what belongs in EWP and a CWP, as well as some IWP templates per discipline for common types of work. Again, these are all kind of industrial focused, but I think they're pretty easily translatable to anything if you just take a little bit of time.
Yes, those templates that are in the appendices for volume 2 of our IR 272 are very useful. We can say that those aren't necessarily the contents, the minimum contents. Those are good examples of the types of information that you could have in an EWP or CWP and so forth. In the end, you'd really want to make your packages fit for purpose. I think I mentioned earlier, you don't overstuff them with information that the user may not need. So there's an opportunity for some flexibility here in what goes into a package. You want to make it something that can efficiently be used, and it gets to the people who are going to use it exactly what they need. And that may vary a little. That can vary from discipline to discipline. As a base case, you typically would picture you're going to need the drawings. What do you need in addition to that, as far as installation instructions and maybe a specification? You might include an appropriate safety content that you wouldn't have been you would have done maybe separately if you didn't have AWP. So there's some flexibility and some options there, and those templates really cover all the different types of information that you might consider putting in.
One of the other questions is how do you integrate different tools and systems to ensure the connection and link along E, P, and C during the entire project lifecycle?
I'd like to take that one. There's at least 4 sponsors of this particular summit that's what they do, because that is not an easy thing. So at least 4 sponsors here. You go to their sites and you'll see that they will provide these services. Some companies are fortunate enough, I happen to be one of them, who has been building our project information management system for over 20 years. So we pretty much have ours under control, but we're probably the exception. I would advise you to seek, if you don't have these systems in place, seek one of our sponsors and they'd be more than happy to help you do that.
Another question is, should AWP always drive WBS structures?
Yes.
Yeah.
Let's make the point that some companies use the term work breakdown structure in different ways. For AWP, of course, we're using WBS as the breakdown structure into packages. construction work areas leading into the breakdown into packages. Sometimes WBS may refer to a more of a contracting strategy breakdown. But anyway, Bill's answer is correct. Yes, for those that appreciate the structure of what AWP brings to taking a complex project, or maybe even one that's not that complex and not that big, but you're wanting to make sure you break it into manageable chunks that you can appropriately steward, track, plan for the resources that are needed. Then whether you're fixing a fence in your backyard or installing a light bulb, you know, a pretty small scope can benefit from thinking in terms of an AWP approach to breakdown of the work. Thank you.
Yeah. Your work breakdown structure is typically the basis by which you set up your project controls. And if your project control structure is not aligned with your work package structure, it's your chance of success in an AWP execution environment approaches zero, would be my sense. So yeah, you have to have all that stuff aligned, otherwise you're missing the value.
Another question, which I think John touched on, is AWP scalable for a portfolio of smaller capital projects?
And the answer to that is yes. I mean, you have to make it scalable, but you can't. We use AWP on every size project. The difference is the degree of automation and tool sets that we use, you know, to achieve that. But we use AWP principles on every project, regardless of how small it is.
And of course, on a portfolio, you have that opportunity to have a planner or planners that are working across that portfolio.
Right.
Thank you.
Another question is, how do you optimize AWP when the CWPs don't offer logical engineering design packages? How do you mitigate it?
For one thing, engineers like to engineer by system. You get into this all the time. And so they'll say, well, CWP is not logical for me, but really you can overcome that one. But I'll tell you a case where you do get in trouble. And we have an electrical E&I contractor here in Baton Rouge. And when AWP first came out, I asked him, said, how are you guys, have you guys had any experience with AWP and how's it working for you? And boy, he literally put out some words that I can't say here in public. It was pretty bad. And he says, these guys are trying to break up a power into a CWP, into an area, and it doesn't work. I mean, a cable runs from a power source to wherever it's going, you know, a pump or whatever. It may cross through 10 CWAs and, 20 CWPs. So you got to use your head here a little bit. Some things just are not, geographically bound. But if it's physical, like lighting, like piping, like steel, like concrete, most of those things can be logically prepared. And the other thing of it is, a lot of people want to optimize engineering. Well, you got to change that mindset. We're trying to optimize construction and fabrication. And sometimes that's at the expense of engineering. We're going to have a lot of out of sequence work and a lot of constrained packages on the engineering side in order to gain the benefits on the downstream side. So it's truly a cultural and a mindset on a lot of people.
We're coming close to the top of the hour, which is our break to end this session and take a half-hour break. Are there any more questions here on this list, Bill or John or Jamie, that you believe we should address before we close our session?
I think we've addressed most of these. The last one that just popped up is there a language or terms definition exchange from processing infrastructure using AWP to vertical construction using AWP? I would say that is one of the things the AWP and Lean working group is starting to discuss. I've been around a lot of different construction now, and there are definitely different cultures and pools in each sector, but at the end of the day, it's still construction. And so you're doing the same stuff, but you're calling it differently. To me, that really the biggest challenge of translating AWP to a commercial or vertical construction environment, as I've thought about it some more, is in the commercial world, because a lot of delegated design is going down into subcontractors and specialty suppliers, that is going to be a bigger effort to bring the engineering home, but perhaps also one that a lot of the people doing that detailed work are going to get on board pretty quickly with AWP and priorities. So in some ways it may be harder, but in other ways it might be easier. But at the end of the day, you're still building projects. You got to get it done, and we're all about the discipline of doing that.
Any other thoughts or comments before we close? Well, we thank you all for your time. We're going to be coming back in half an hour and focusing on the SWOT and AWP and Lean. Want to thank our panelists for their efforts putting this all together, and we'll see you in 30 minutes.